Let's take a look at the definition of an elementary disjunction in propositional logic. So a formula is an elementary disjunction provided it has the form a sub 1 or a sub 2 all the way up to a sub n, where n is a number greater than or equal to 1, and where each one of those a's is a literal well-formed formula. So let's look at some examples. Let's start with cases where n is equal to 1. That is, we're simply looking at a formula. So what we're doing here is looking at a formula where it's just a sub 1. It doesn't necessarily need to be a disjunction. So in order for a formula to be an elementary disjunction, it needs, as the definition states, to be a literal well-formed formula. So what this would mean would be that P, not Q, R, not S, all of these formulas, which are literal well-formed formulas, are also elementary disjunctions. In short, single propositions can be elementary disjunctions, even though they are not disjunctions, provided they are literal well-formed formulas. Now let's look at a case where n is greater than 1. So in this case, what we would need is a formula of the form a sub 1 or a sub 2, and it could be larger. It could go all the way up to a sub n. The condition associated with elementary disjunctions is that each one of these a's, each one of these formulas, needs to be a literal well-formed formula, and each one needs to be connected using a disjunction. In other words, each one of the disjuncts of a elementary disjunction needs to be a literal well-formed formula. Let's look at some examples. So P or Q, notice this has the form a sub 1 or a sub 2. It's a disjunction. And since each one of the disjuncts is a literal well-formed formula, this would be an elementary disjunction. Next, let's take a look at P or Q or not R. Notice again, this is a disjunction, and each one of the disjuncts is a literal well-formed formula. So this too would be an elementary disjunction. Let's look at one more example. Let's say we had P or not Q or not R or not S. Notice that this formula has the form a sub 1 or a sub 2 or a sub 3 or a sub 4. Also notice that each one of the disjuncts of this disjunction is a literal well-formed formula. So you could go through each one and see, this one's a literal, this one's a literal, this one's a literal. And so what we have here is also a elementary disjunction. Let's look at two formulas that are not elementary disjunctions. So first, let's look at P right arrow Q. If we took P right arrow Q and treated it like a single formula, in order for it to be an elementary disjunction, it would need to be a literal. But since it is not a literal well-formed formula, this formula is not an elementary disjunction. Now you might say, well, maybe this formula can be of the form a sub 1 or a sub 2. If it were, and a sub 1 and a sub 2 were composed of literals, then it would be an elementary disjunction. You could point to the fact that P is a literal and Q is a literal. The problem is that in order for it to be an elementary disjunction, it actually needs to be a disjunction. But notice that this formula right here is a conditional, and so in this case, it would also not be an elementary disjunction. So P right arrow Q here is not an elementary disjunction. Let's look at one more example. Let's say we had not P or Q. If we had not P or Q, we might be tempted to say, well, look, this formula has the form a sub 1 or a sub 2. The problem with this idea is the fact that the formula is not composed of literals. Not P here is not a literal. And since it is not a literal well-formed formula, it is not a disjunction composed exclusively of literals. And so it would not be an elementary disjunction.